everyone. My name is Akshita Sanvi. I am a third year undergrad at Nitya Meenakshi Institute of Technology, pursuing computer science and engineering. Today I'm going to present my SIC capstone project, which is PanPath AI. It is a smart driver assistant which helps us to detect hazards and in smart navigation. So PAN basically means comprehensive, and path is the route which we are taking or traveling. So it helps us to traverse a safer path, which we cannot find through ourselves, as we can't detect hazards in real time. So what this does is, this model is designed to predict hazards. It monitors traffic and weather and everything needed for us to take a safer route. So let's go through the code. So we have taken a ResNet 18 model, which is a deep neural network which has 18 layers. It has a special property of skipping connections, but it maintains a high accuracy. So we have fine-tuned the ResNet on around 2,300 images of normal roads, potholes, and floodings. So I could get the data set from Kaggle for both potholes and floodings, but for normal roads, I was not able to get more data sets. So I applied data augmentation to the number of roads I got. So I'll show you. Through this code, I have fetched the data sets. As you can see, I've used Saurav Sahane's data set and Anju MVD data set. And I have fetched the normal roads data set through here. And then I have divided the data for training and validation. 80% was for training and 20% was for validation. And after dividing, I have trained the model. So I'll show you. So as you can see, heavy augmentation is done on the normal roads. And we have initialized the ResNet model, and we have frozen 100% of pre-trained feature extraction layers. So the backbone is frozen, and we'll unfreeze only the final classification head with 50% dropout. And then we have optimized only the final classifier parameters of the model. So the training has been done, and we have evaluated the model. It has around 96% of accuracy, and I'll show you the classification report and ROC curve. This is the confusion matrix. As you can see, there are less number of misclassifications, which accounts for the reliability of the model. And this is the ROC curve, which is TPR versus FPR. So this is done. So the vision part of the model is done. And for voice, since we'll be driving, so we want our hands to be free. So we can't use our hands for typing the locations or knowing our route. So I have incorporated a voice assistant. It uses Llama 3 model, and through Whisper, it converts our speech to text form. The voice part is done, and so now let's come to the backend part. So this is the routing engine code. So this is used for finding the path, the route. And this is the satellite telematics code. It fetches through Open Meteor Weather API and Open Elevation API to analyze the path ahead. And this app.py is the core of the backend. As you can see, so there are around 11 API endpoints used. I'll show you the endpoints. So this is the first endpoint. So this basically checks that the server is live, and this the hazards. It checks all the stored hazards with GPS locations and log hazard. Suppose if we are traveling and we encounter a hazard, so we don't need to feed it manually. It will automatically log itself. And traffic, as I told you, I have used TomTom traffic API. So it analyzes the traffic situation in real time and reroutes accordingly. And this is the auto ingest telemetry, just for the sake of it itself manually, not manually feeding it. It itself feeds the data required. And the predict image. So when we are traveling, if we encounter, say, a pothole or a flooding kind of obstacle, then the camera will see, the resonant model will predict, and we'll get the warning. And for that, I'll show you what the code I've written. Here in Vision, we have stream processor.py. So this is used for live streaming. It predicts the hazards in real time, and it gets back here. Yeah. And then the zone evaluates. So it basically evaluates the paths to be taken from satellites and the traffic situation or the hazards which are already there in the database. So this was about the backend part. And now I'll show you the front-end part. Yeah. So I have deployed it using Streamlit. As you can see the code. All right. So now let me show you the model. So suppose you want to go from Mangalore to Mumbai. So simply tap here and say, navigate from Mangalore to Mumbai. Send. My destination has been updated. Now the path is being calculated. So we have used OSMR for primary routing, which has contraction hierarchies plus bidirectional Dijkstra. And if rerouting has to be done, then it uses OSMR alternatives. It's getting updated. So since there was a hazard detected, rerouting has been activated, as you can see. You can see the map. This is Mangalore. So the red one is the direct path, which we do not have to take as it is not safe. This one, the line, blue line is the path, which we have to take as it is safe. All the hazard zones have been detected, as you can see. So here we reach Mumbai. You can see the hazard legend, traffic legend. And you must be thinking like, how will it predict the hazards on roads in real time? Let me show you how. So this is the dashcam vision analytics. It's loading. Suppose I'm traveling and my path looks like this. As you can see, this is flood. So it is showing flooding. Alright. And now if I'm traveling on a safe route, well, suppose it's a normal road with no hazards. So if my view is like this, it gets predicted as normal. Now suppose if there are potholes on the road. As you can see, pothole has been detected successfully. So this is how live camera feed will work. And there are also traffic controls here, and you can also refresh the map and locations, or you can reset to your default locations. And there is also an option for swapping locations, like if you want to swap the starting and the destination, just click here and it will be swapped. Now start location is Mumbai and destination is Mangalore. And now the path will be rerouted again. It's being loaded. Since it's working on CPU, it's kind of slow. Again, we have the route here on the map. So the map has been updated. And you can refer the hazard legend and the traffic legend for information. And if we are taking direct route, then it shows direct. And since here it is rerouted, the status is rerouted here and the traffic is normal, means we can go. There is very less or no congestion in the way. So yeah, that's it for my project. Thank you for your patience listening.